Okay, a chemical reaction involves the breaking of chemical bonds in the reactants. So I have to break the reactants bonds and then to form new bonds or to form new products. Okay, and then this one involves energy change. So bond breaking takes in energy, is exothermic, right? I have to absorb the energy to break these bonds. And then bond forming gives out energy, and this is exothermic, right? So why do elements form bond? Because they want to achieve the noble gas configuration, which is stable and of low energy. So this energy will be given out, and it is exothermic reaction. Okay, so to break energy, it must be absorbed, and it is endothermic. To break bonds, energy must be absorbed, and it's endothermic. Okay, and then bonds are formed because they want to achieve noble gas, which is lower energy, and then making it stable. So this energy is given out. So bond forming energy is given out, and it's exothermic. Okay, so the enthalpy change, this is the delta H symbol. This is the difference between the energy level of reactants and products. So how much energy does the reactant have minus the product? All right, so in all chemical reactions, I have to break bonds before I can form bonds. Right, so in all chemical reactions, the delta H will be the break bonds minus the form bonds, the enthalpy change, or the delta H will be equals to bond breaking minus bond forming. Okay, so if less energy is absorbed to break, then released to form. So if, for example, I absorb 500 kilojoules against I form 1000 kilojoules, the overall enthalpy change will be negative. So this is the part where I absorb, this endothermic, and then this is the part where I release out, and it's exothermic. So I release more, so the overall is exothermic. But the important idea is because a small number minus a big number, the energy change is negative. Okay, and then if more energy is absorbed to break than to form. So if I take in 1000 kilojoules to break the bonds, against I release 500 kilojoules when I form it. So there's more energy breaking than forming. The overall reaction is endothermic because I absorbed more energy. And then you see that if I take a big number minus a small number, my value is positive. So this is endothermic. Endothermic reactions, the enthalpy change is positive. Okay, so explain common questions, yeah? Explain in terms of bond forming and bond breaking why reaction of hydrogen and oxygen to form water is exothermic. So hydrogen and oxygen forming water, in the first place, even if they never tell you it's exothermic, this is a combustion reaction. Because oxygen is involved to give me energy. Energy is given out, it's exothermic. Okay, so how do we explain it? Energy required to break the bonds in hydrogen and oxygen is smaller than energy required to form bonds in water. Okay, so repeat myself, energy required to break bonds is smaller. So I have a small number, example 500. Okay, it is smaller than the energy required to form these bonds. I minus 1000, I will get a negative value, and it is negative value, and it is exothermic. Why? Because more energy is released when I form the bonds. Okay, so this explanation is good for combined science, but if you are doing pure science or IP science, right? The delta H is negative, the enthalpy change is negative because energy taken in to break 2 moles of hydrogen bonds. Why is it 2 moles? Because there's H2 and there's 2H2 in the balance equation, and 1 mole of oxygen bond is smaller than the energy given out to form 4 moles of OH bonds in water. Okay, so for O level, they will expect you to write 2 moles of hydrogen bonds, 1 mole of oxygen bond because in the balance equation, and then to form 4 moles of OH bonds. If you cannot tell this is 4 moles of OH bond, then please write 2 moles of water molecules.